Hi, I'm Andre Jennings, Senior Writer for The Absolute Sound, and today I have Dr. Roland Gauder from Gauder Acoustics in Germany here today to deliver his DARC 250 Mark II loudspeaker. Before we start talking about the Gauder DARC 250, Dr. Roland, could you please tell us a little bit about the history of your company?
Yeah, I will. Thank you very much for inviting me here to come here over to Cincinnati. And the hi-fi business since many, many years, and our company started in 1997, so 25 years ago, when I started my own company and built isophone speakers at those times. And now since 12 years I have my own company, Gauder Akustik, and the products are just covered with my name on it. And here the DARC 250 is now the top model of the DARC line, and it's a very sophisticated speaker, and it took me a long time to calculate the speaker, believe me. It's a four-way speaker with two woofers, a mid-range and a diamond for the mid-range, and the tweeter also made of diamond, so the best materials you can get. But I want to tell you something more about the speaker, which is really much more interesting than only the materials or something like that. Also, you see, you touch the aluminum cabinet. That's fantastic.
All right, well, great. Speaking of the aluminum cabinet, can you just give me a little rundown of what we see here? Because it looks like we've got a rib construction with damping between them.
Yes. The DARC means dynamical aluminum rib construction, and the rib construction is very, very important. It's crucial to this design, because if you build a speaker made of aluminum, the cabinet is really ringing, and it's hard work to dampen it with all the dampening material inside, the bracing and so on. So actually in the 90s I tried it with aluminum, but it was terrible. It didn't work. The sound was ringing, and it's so metallic. It was not natural, and I stopped the project at those times. But with the rib technology, I can do it now. Here you see we have our aluminum ribs.
Yes.
They are stacked one over the other, and now comes the trick. There is a fiber material in between those ribs, and this fiber material dampens the ringing of the cabinet. And so if you put your hand on the top cover, it's of massive aluminum, you will not feel a single tone on it. Normal cabinets, they ring, and you can feel the music play, but not with the speakers here from the DARC series.
Okay.
They're totally quiet.
So it makes the cabinet fairly inert. Now I remember 7.5 years ago, I had the Berliner RC9s here,
Yeah.
and they had a similar rib construction. So
Yes.
that rib construction was something that you had considered ahead of time, even before the DARC series. Is that
Yes,
correct?
absolutely. It came from the idea that cybernetics is just a fine science, and cybernetic means how does nature produce a loudspeaker if it's necessary. And so we thought, yes, nature produces something like just a belly and the ribs here and the spine for stability, and so we have our volume enclosed here and protected, and that's the idea. So if nature builds it like that, we can do it in this cybernetic way, and that's how it started. And in the beginning we started with the wood as material for the ribs.
Uh-huh.
But of course, it's it's quite close. You think about it and then say, oh, why don't we use aluminum? Because aluminum is 4 times more dense than wood, and it has a much better base isolation, keeping the energy inside the cabinet.
Okay.
Because you see, for wood, it's a big problem to keep the sound inside for low frequencies. The low frequencies go through. And then you have the resonating of the room and all these bad echoing and spoiling effects.
Okay. So you got the rib construction here, you have the damping pads that are in there, and then those are stacked up. And so you've got some type of bracing to keep everything together. Is that how that's done?
Mm-hmm.
Okay. Okay, well that's good. And then let's see, the drivers, you said we've got some diamonds up here, a little bit different than what's on your hand, I take it. But
Yes.
we've got some diamonds here,
Yeah.
and then the mid-range.
The ceramic mid-range driver.
Okay.
Yeah, and then we have the woofers made of aluminum with some coating on the back to stiffen it
Okay.
and to give the right mass, because you know woofers must be heavy.
Yes.
So they have a low resonance frequency, so we have really low bass in the low end of the music spectrum. But mid-range drivers must be very light, and woofers should have a small magnet, and mid-range and tweeters, they should have a high magnet, a strong magnet, as strong as can be, because these magnets must accelerate the diaphragms to these unbelievable things. Imagine 20,000 times per second this diaphragm is moving back and forth. That's enormous.
Yeah.
So you need a strong force in the low mass for getting these high accelerations.
Okay. Okay. And so the diamond cone material, what makes that special for you?
It's light.
It's light.
And it's stiff.
Yes.
And it has a high heat conductivity, and it has a very, very high speed of sound. And this is all positive, very positive for the material. But as you see, a diamond of that size, it's not cheap.
Okay.
It's very expensive, and it must be made in a very, very special way. And actually, we have to make a forecast every year how many diamonds we need, because they cannot be produced in amounts as we want.
Okay.
It's just a very, very tricky procedure.
Okay. And then all of these drivers you have here that you're using in the DARC 250 series, and then also in some of the other series that you make, these are not off-the-shelf drivers. Is that correct?
Of course not. It cannot be. They need to have the specialty, the small parameters, because I make a lot of mathematical calculations before I start with developing. And I get the solutions from all these equations. And so these equations tell me the small parameters I need. Otherwise, I cannot produce the filters I would need. You see, I use filters with 60 dBs per octave steepness.
Okay.
So 60 dBs, that's really steep, and these drivers must have the perfect parameters, otherwise it doesn't work.
Okay. So before we get to the filters, your drivers you have equations for each of the drivers to model them, and they're special. Each of the drivers are special to your specification.
Absolutely.
And that allows you to plug those equations in to a larger group of calculations that you use, which revolve around the crossover. So you talk about the crossover being the heart of this speaker. So can you tell us a little bit about what the crossover is, how you designed it, and how you achieved what you got out of this speaker?
Yeah. Actually, the crossover really is the heart of each speaker. Doesn't matter which material or driver you use. The crossover must give the right filtering and the right signals to each component in the speaker. And that's the big trick, because people always think, I say a crossover, it starts at 100 and it stops at 1000 hertz, and then it's over. But that's not the case. In analog technology, we have very, very flat slopes. And so all the drivers, they interfere very, very much if we use a flat filtering like 6 dB or 12 dB, which is normal. But then you have a big frequency band which is overlapped by mid-range and mid-high or tweeter or woofer. And so the same signal is sent out from the speaker from 3 or 4 different drivers. And we all hear this with our ears, all these interferences. And that's really the big problem, because we lose the phase information. That means we lose the spatial information and also the impulses. We lose the impulses. The impulses get smeared. And then the thing happens that you listen to music and you cannot understand what the composer really meant to you, to say to you with this music, because it doesn't come out as he produced it with his band or his orchestra. And so I said, we must reduce this interference band very, very hard. And that's why we use 60 dB per octave crossovers. That's very cost effective. I know it's very extensive, but it's the only way to build a wonderful high-end speaker, better than the usual speakers. And also we use symmetrical crossovers. That means the driver is not grounded like in normal crossovers, but it sits in the middle, and half of the frequency crossover is in front of it and half between it. So the amplifier is always just blocked by the filtering inside, and there is no big feedback from driver to the amplifier, and that helps the amplifier to build a perfect image of the impulses coming from the CD player or the turntable. And the thing is that it's not easy to do that, and it's a four-way system, so you must really make mathematical calculations. Otherwise the system is so complex and so difficult, you cannot guess it, how the real values are.
Okay, so with that in mind, if the crossover is really complex like that, and you have a lot of work to do, that means a lot of parts in the crossover and a lot of calculations. So how did you come up with getting all these nonlinearities to work right, and how many components do you have inside of the speaker?
Yeah, we have 68 components, 68 conductors, capacitors and resistors inside the crossovers. We have 4 PCBs for each way, 1 PCB, one is doubled each. So you see, that's a big effort. But this really means that all the single drivers get the perfect signal, and all these signals are in phase, so we do not lose the phase information. If we measure the phase of the speaker, it's just like a linear, it's a line. There is no bumps, no dips, no highs in it, and that's really the trick why you can sit down here or here or here. That's important, because with our speakers we want to create an acoustical image of the original event, and the more realistic this image is, the more we can understand what the composer meant. And for me, this is the crucial thing in hi-fi. We have the composers, maybe the Beatles, or maybe Freddie Mercury, or maybe Mozart, doesn't matter. They want to tell us something with their music. They want to give us emotion. And the more realistic the image of the loudspeakers and the system is, the more and the better we understand the message of the composer.
Just a brief interruption, esteemed viewers. As you may know, I'm Tom Martin, Chief Content Officer of The Absolute Sound. We have a new product. It's on the Substack platform, and we're going to do some interesting things with Substack. First of which is reader questions and answers. Each Monday, readers will submit questions, we'll pick the most interesting ones, and we'll answer the questions on Friday. We'll also have early access to articles and special blogs that don't appear anywhere else. We hope you'll join us. It's only a cost of a cup of coffee per month. Just check on the screen or in the show notes below. Thanks, and now back to the show.
With all that said, how did you get all those calculations? If you've modeled the entire speaker, how did you get all those calculations to meld, and what process did you use to do that?
Yeah, I just I tried it with Wolfram Alpha. It didn't work. It's too complex, and I made a 2-week seminar on R, which is a new type of mathematical software. But even that could not solve this. It's too complex. But I'm happy I still have the relationships to the University of Stuttgart. In Stuttgart we have one of the biggest computers in the world, and so I could use it. Let's say it like that.
Okay, well, great. Well, that's good to know. Now, since you've talked about the crossover, the drivers, and the cabinet, there's some adjustability on the back of the speaker and then underneath. Can you tell me, there's 3 adjustments that are available? Can you tell me what those are?
Yes. Yeah, that's the big point for you as a customer. You have a home, a living room, a listening room, and you want to play music there, but the speaker is too big or not big enough or whatever. And you cannot adjust a normal speaker to your room. And that's why I said we must think about this. And so we invented something which is called bass extension. This is just one thing. We have a box here with different modules. And the white modules here just are used here for the DARC 50 because the white modules of this set fit it best to the room here. And this is something we have called the bass extension, because the low end between 30 Hertz and 70 Hertz of the roll-off of a bass curve is just very critical in any room, because that gives you the place and the position of the speaker to be best. And we can adjust it with these modules. We can adjust the roll-off and can give more energy or less energy. And then we can set up the speaker really to any room. Also, the next thing is in the back we have the jumper settings, so we can adjust the volume of the bass. Plus 1.5 dB, linear 0 dB, or maybe minus 1.5 dB if the room is very small or the speaker stands in the corner. And also we can do the same thing for the highs. And this is just very, very effective. And with this method, it's just possible to use 99% of the room and make a perfect adjustment. But of course, this must be done by a good dealer or a professional acoustician.
Okay, so we've got the modules that are plug-in that you can use, and that adjusts from 30 Hertz to 70 Hertz,
Yep.
which is typically a range of where a lot of bass bumps in the rooms occur. So it gives you a chance to lower those bumps that are there to
Yes.
get a more linear bass response.
Yes.
Now, you did mention the adjustment for the woofer and then the adjustment for the tweeter. Can you tell me, bringing the level up and down? So can you tell me what range those are functioning in?
Yeah, the woofers, they work from 20 Hertz up to 150 Hertz.
Okay.
So you see, 20 Hertz means I have a high pass filter in front of the woofer. So they do not get subsonic shares of the music. So I stop at 20 Hertz and say below 20 Hertz nothing happens for music, and I stop it there with a high pass filter of second order, and then the woofers go out at 150 Hertz. So that's very early, but the equations tell me to do that. Otherwise it will not work. And so the mid-range driver with the 7-inch ceramic driver here starts at 150 and goes up to 1200. And from 1200 Hertz to 5000, the big diamond mid-range driver is working. And from 5000 Hertz upwards to 80,000, it's the tweeter.
Okay. Okay. So from 20 Hertz to 150 Hertz,
Yeah.
the bass level adjustment takes place.
Yes.
And the reason it doesn't do anything below 20 Hertz is because you have a high pass filter in there. And so if
Yeah.
you got rumble from your turntable or other things going on,
Yes, yes.
it doesn't tax the amplifier, it doesn't tax the speaker, and so
Absolutely.
you get a little more clarity. Now, what about the high frequency adjustment? What range does it cover?
Yeah, the high frequency adjustment is just for the tweeter, because
Okay.
that's a critical thing in the room. And some people like more highs to get more details, and some people say it's too nervy or something like that. So it's a matter of taste always.
Okay.
But in some rooms you have bad reflections from windows and walls. In some other rooms there is damping inside, absorption, so you need more highs. And this is very critical in the low end and in the high end. The mid-range is just with the wavelengths, they are still so big that they don't touch a little bit of this absorption problem. But the highs are very critical to that. And so you can set the level of the highs 5000 Hertz upwards to infinity, also with the jumper in minus 1.5 dB, linear, or plus 1.5 dB.
Okay. All right. Well, I think this covers most of what we are interested in about this speaker, and so we can look forward to a review of this in the Absolute Sound in an upcoming issue.
Mm-hmm.
Is there anything else you want to tell us about maybe some of the other speakers in the line,
Yeah.
size-wise, or how many speakers in the line do you carry?
There's some. This is just the most important point now. That's why I kept it for the end. This speaker comes with a new technology which has never been used in hi-fi before. You see, the problem with the crossover is always we have a group delay. That means a signal goes into the crossover and the inductors, they delay the signal. So the signal is coming right through, but it's delayed in time.
Yes.
And the bigger the crossover, the inductors are, the more the delay. So we have a delay between woofer, mid-range, mid-high, and tweeter. And that leads to normally a smeared impulse. That's what I talked about in the beginning.
Yes.
And with this new technology, I make a time delay for the tweeter and for the mid-high. And so the mid-range and the mid-high and the tweeter, they shoot at the same time. And that's very, very important for the impulse response. That's why the speaker has such a good transient response and attack. And this is just the heart of the DARC series and the heart of all our speakers now. The Capello series, the Berliner and the Arconas, they all come with this technology. And therefore, if you listen to one of our speakers, maybe you start with the smallest one, the Arcona, which is very cheap in comparison to this one, or you go up to our Berliner RC11. They all have the same technology inside, and you can hear it immediately by listening to guitar, piano, drums, or even singing. It's so clear, it's so good in attack, the impulse is absolutely perfect and the phase is linear. And that's amazing. Then you listen to this, you think after 10 seconds, that's something new. And so we have 4 lines, the Arcona for beginners with 4 speakers, Capello with 3 speakers, Berliner, the famous Berliner series, and now the DARC series 2 with 7 speakers, and the top of the line, the DARC 250 now standing here. And they all feature the same technology, and that's what really is different to any other speaker in the world.
All right. Well, Roland, I want to thank you for giving us some time to give us a preview of the speaker. And for the listeners of The Absolute Sound and those who are watching the YouTube channel, hopefully you've got an idea of what the preview of this speaker will be like. And of course, look for the review in an upcoming issue of The Absolute Sound. Thank you very much.